I want to remind everyone x plus 4 over x plus 4 or x plus 4 over 4 plus x both equal 1 because we can add in any order. So these are the same. But if we had x minus 4 over 4 minus x, that would equal negative 1 because these are opposites. If we were asked to find the LCD, least common denominator, of x plus 4 over x minus 3 and 1 over 3 minus x, since these are swapped, x minus 3 and 3 minus x, since they're opposites, since we use that -1 trick when we're simplifying these, we can choose either x minus 3 or 3 minus x as the LCD. And again, that's because we can factor a negative out of either of these and get the other. And then if we multiply the negative through the one we didn't do, we get the other. So just keep in mind we can use either for these, and the -1 will correct along the way. Let's use this x squared over x minus y plus y squared over y minus x. Okay, so we don't really need to go ahead and find a common denominator because we notice, hey, the -1 trick is going to make these the same. The -1 trick is that I can multiply top and bottom by -1. And multiplying the -1 through the bottom will switch the order to x minus y. And then -1 times y squared is -y squared. We can see what happens. We have x minus y on the bottom, but this would be x squared plus -y squared, which is x squared minus y squared, plus a negative is minus. And we factor, that's a difference of squares, x plus y times x minus y over x minus y. Those cancel. And we're left with x plus y.
Seven over x minus 1 plus 10x over x squared minus 1 minus 5 over x plus 1. If we factor the denominators that can be factored, that's only the second one. X squared minus 1 is x plus 1 times x minus 1 because it is a difference of squares. Our unique factors are x minus 1 and x plus 1. We want to rewrite all of the rational expressions with that denominator. The first one was just missing an x plus 1. So we multiply by x plus 1 over x plus 1. The second one was not missing either of them. So we don't change that at all. The third one was missing the x minus 1, so we multiply by x minus 1 over x minus 1. And really, there should be parentheses around that. We should never write it like this without the parentheses. Speaking of parentheses, let's distribute on the top. 7 times x plus 1 is 7x plus 7. 5 times x minus 1 is 5x minus 5. Now, we'll take what we have, we'll keep the common denominator, and we will add and subtract across the top. Be careful. When we're subtracting rational expressions, we have to be sure that we're subtracting the entire numerator. So this is 7x plus 7 plus 10x minus the entire 5x minus 5, which means we are subtracting 5x, and we are also subtracting negative 5. Minus negative 5 gives us plus 5. Combine like terms, 7x plus 10x is 17x, minus 5x is 12x. 7 plus 5 is positive 12, so we have 12x plus 12. That factors. We can factor out a 12. We're left with 12 times x plus 1. The x plus 1's cancel, and we're left with 12 over x minus 1. And that is it for this topic. The topic is simplifying complex fractions. The first objective in this topic is simplifying complex fractions by simplifying the numerator and denominator and then dividing. So complex rational expressions or complex fractions are rational expressions whose numerator, denominator, or both contain one or more rational expressions. In other words, fractions inside of fractions. There are two methods that we can use to simplify complex fractions. And method one is to simplify the numerator and denominator of the complex fraction so that each is a single fraction. Then perform the indicated division by multiplying the numerator of the complex fraction by the reciprocal of the denominator of the complex fraction. In other words, taking the top and dividing by the bottom, multiplying by the reciprocal. And then, as always, simplify if possible. So what does that mean? Let's take a look at x over 2 plus 2 all over x over 2 minus 2. Method one is to add the top, subtract the bottom, and then divide top by bottom. In order to add on the top, we need a common denominator. In order to subtract on the bottom, we need a common denominator. That common denominator will be 2. 2 is 4 over 2, so plus 4 over 2 on top and minus 4 over 2 on the bottom. Adding on the top and on the bottom gives us x plus 4 over 2 on top, x minus 4 over 2 on the bottom, and then we can do top divided by bottom, which is top times the reciprocal of the bottom. The 2's cancel, and we're left with x plus 4 over x minus 4. So that's method one. Objective 2 in this topic is to simplify complex fractions using method 2. Method 2, I refer to as the LCD method. If we multiply the numerator and the denominator of the complex fraction by the LCD of the fractions in both the numerator and the denominator, we can then simplify and be done. Because multiplying the numerator and the denominator of the complex fraction by the LCD is going to turn it from a complex fraction into a regular old fraction. What does this look like? Well, let's do 1 over y squared plus 2/3 all over 1 over y minus 5/6. The LCD of all appearing fractions. We're looking for the LCD of the d's. Y squared, 3, y, and 6. 6 is 2 times 3. So our unique factors are y, 3, and 2. Our highest power of y is squared. Everything else is just first power. So y squared times 3 times 2, or 6y squared. Let's multiply both the numerator and the denominator by 6y squared. Notice that's something over itself. That's multiplying by 1. We're not changing the value. Since we're multiplying by the entire numerator and the entire denominator, we effectively are just shoving this 6y squared into every numerator in this problem. 4 spots. 6y squared times 1, 6y squared times 2, 6y squared times 1, 6y squared times 5. Six y squared over y squared, the y squareds would cancel, leaving us with just 6 in the top left. 6y squared times 2 over 3 would be 12y squared over 3, would be 4y squared in the top right. See, the fractions are gone from the top now. 6y squared times 1 is 6y squared, divided by y is 6y in the bottom left. And then 6y squared times 5 is 30y squared, divided by 6 is 5y squared in the bottom right. And that one is minus. And that's it. It's simplified. We can factor a y out of the bottom, but that doesn't give us anything that cancels, so there's no reason to. X plus 1 over y all over x over y plus 2. The LCD is y. So multiply the numerator and the denominator by y. Y over y doesn't change anything. That y on the bottom, just to clarify from the last example, distributes. So both terms get multiplied by y. We didn't actually see that step in the last problem. We did it, but we didn't see it. Now things cancel. On top, the y's cancel, leaving us with just x plus 1. On the bottom left, the y's cancel, leaving us with just x. And the bottom right, y times 2 is 2y. An example of a complex fraction would be this fraction that has fractions inside of it. That's what we mean by complex fraction. Since one way to think about this is top divided by bottom, this is actually the problem 1 over 4x
minus 3 halves divided by 3 minus 1 over 2x. Top divided by bottom. Just like if we had 36 over 9. Why is this 4? Well, because it's a division problem. 36 divided by 9. So top divided by bottom. So we'd subtract these two. We would have a common denominator of 4x. Two times what gives us 4x? 2 times 2x. So we would have to do the 3 times 2x. Nothing changes here. This gives us 1 over 4x minus 6x over 4x. Which gives us 1 minus 6x over 4x. Now that's just this first one. And why was it in parentheses? Well, because it's top divided by bottom, which means we have to simplify the top completely. We have to simplify the bottom completely. That's represented by the parentheses around each of these. Notice without the parentheses, we would have this division problem in the center, 3 halves divided by 3, and that would have to come first by order of operations. So to make sure we do this correctly, if we write it like this right off the bat, we need to keep it in parentheses for the numerator, keep it in parentheses for the denominator until we get to a single fraction, until we have fraction divided by fraction. What do we have going on over here? Well, 3 is 3 over 1. And this would be 3 times 2x over 2x minus 1 over 2x. 3 times 2x is 6x minus 1 over 2x. Fraction divided by fraction. We'll pick up here in a second. Where's this going? If instead of writing it as a division problem right away, we wanted to start simplifying first, we can do that, but we would have to show it. 1 over 4x minus 2 times 2x is 4x, 3 times 2x on the top. That's 1 minus 6x over 4x. Bottom, 3 over 1 would be 3 times 2x over 2x. Minus 1 over 2x, that's 6x minus 1 over 2x. And once we have fraction over fraction, single fraction over single fraction, that's fraction divided by fraction. Fraction divided by fraction. So it's the same thing up to that point. So method 1 is going to be the fraction divided by fraction method. However we get to fraction divided by fraction. I showed it two ways. The first way, I started numerator in parentheses divided by denominator in parentheses. Simplified them both. Got to this point. The other way I got to this point was simplifying the top, simplifying the bottom, and then writing it as a division problem. From here, how do we divide fractions? Keep the first fraction, write division as multiplication, flip the second fraction. We can cancel. 2x over 4x, that's 1/2. 1 minus 6x over 6x minus 1. Remember, these are opposites. The opposite of 1 minus 6x is -1 plus 6x or 6x minus 1. When we flip around the subtraction sign, we get opposites. What happens when we divide opposites, have an opposite over its opposite? It's -1, so -1 over 1. What do we have here? -1 times 1 is -1. 2 times 1 is 2. -1 over 2 is -1/2. Now, you might have caught on to the fact that I referred to fraction divided by fraction as method 1. That means there's a method 2. And method 2 is actually going to be more helpful in our next lesson than it is here. But it is a shortcut, as it were. And it relies on getting not the LCD of the top, not the LCD of the bottom, but the LCD of both. Taking all of the fractions into consideration, taking the LCD of that. So the LCD of all, we're looking at 4x, we're looking at 2, we're looking at 2x. Why aren't we looking at 3? Because 3 is 3 over 1. And 1, we can multiply by anything without changing it. That means 1 doesn't really come into play. So 4x, 2, and 2x, the LCD is going to be 4x. Here's the shortcut. We're going to take the 4x and we're going to multiply it in every term. 1, 2, 3, 4 terms. We're going to multiply it in the top. So 4x times 1 over 4x minus 4x times 3 over 2. All over. Not what we originally had, but what we originally had where the tops are all multiplied by 4x. Let's take a look at why this works. I want you to consider the number 1. 1 is anything over itself. In this case, we're using the LCD over itself. And the LCD is the LCD over 1, because anything over 1 is itself. LCD over 1. And if we were to multiply the LCD over 1 through some complex fraction, notice the 1 would distribute through the bottom and the LCD would distribute through the top. The bottom doesn't change, but the top, every term now has the LCD multiplied into it. So, by that logic, taking the LCD and multiplying it in the top of every term is the same as multiplying the complex fraction by 1, which doesn't change its value. And that's why we're allowed to do it. Okay, that's why it worked. But what happened? Why did we do it? Well, the reason we did it is because now it's not going to be a complex fraction anymore. Things are going to cancel in such a way that there are no more fractions inside of the fraction. 4x over 4x is 1 over 1. 4x over 2 is 2x over 1. Over here, nothing changed. Over here, 4x over 2x is 2 over 1. Now, this isn't canceling. Let me be very specific here. The x's are only canceling in those. The x is left behind here because we're not canceling a 2x on the bottom. We're just canceling a 2. This turns us into 1 minus 6 over 4x times 3 is 12x minus 6x up top. 6x up top. Just made a big deal about that x not having been canceled. Minus 2. If we factor a 2 out of the bottom, that's 6x minus 1 over 1 minus, on top, below 1 minus 6x. The 1 minus 6x and the 6x minus 1 cancel to give us negative 1. And that's over 2. Negative 1 over 2. Negative over positive is negative overall. Negative 1/2. Same answer. So now that I've explained the two methods, and I've explained why each works, let's use both methods on 4 minus 6x over 2x minus, 2 over x minus 3 over x squared. Well, fraction over fraction, this is going to be 4 minus 6 over x divided by 2 over x minus 3 over x squared. This is 4x over x minus 6 over x divided by 2x over x squared minus 3 over x squared. This one got multiplied by x over x to get the common denominator, as did this 4 get multiplied by x over x, the 4 over 1. This is 4x minus 6 over x divided by 2x minus 3 over x squared. Or, you work on the top until the top says 4x minus 6 over x. Then you work on the bottom until the bottom says 2x minus 3 over x squared. And then you'll turn it into, since it's fraction over fraction, fraction divided by fraction. So method 1 gets us here. And then we continue. 4x minus 6 over x times x squared over 2x minus 3. Because fraction divided by fraction is fraction multiplied by reciprocal. We can factor a 2 out of the 4x minus 6, giving us 2 times 2x minus 3 over x times x squared over 2x minus 3. The 2x minus 3 over 2x minus 3 cancels. One of the x's from the x squared cancels with the x on the bottom. And we are just left with 2 times x, 2x. Method 2. The LCD of everything. We have an x, we have an x squared. X squared is going to be the LCD. So 4 times x squared minus 6 times x squared over x over 2 times x squared over x minus 3 times x squared over x squared. See, originally we just had the 4, not the x squared, and then we had the 6 over x, but not the x squared. We had the 2 over x, but not the x squared. We had the 3 over x squared, but not the x squared on the top. Now things cancel. And we're left with 4x squared minus 6x over 2x minus 3. Factor a 2x out of the top. We're left with 2x times 2x minus 3 over 2x minus 3. The 2x minus 3's cancel. We're left with 2x. Same answer. Next, let's take a look at 1 over w plus 3 minus 1 over w minus 3 all over 1 plus 9 over w plus 3 times w minus 3. Let's go ahead and use both methods again. The LCD of the top is going to be w plus 3 times w minus 3. So we already have the w plus 3. We're going to need w minus 3, which we have to put over itself. Remember, this one doesn't just go in the top. Here we're turning this into fraction over fraction, which means we have to make sure every fraction has the same denominator, and then simplify. Minus 1. We have the w minus 3 on the bottom. We need a w plus 3 over itself. And then here, 1, let's just make that w plus 3 times w minus 3 over itself. Because we need to add it with this, and this already has a w plus 3 times w minus 3 on the bottom. So since 1 is anything over itself, we can just decide that we want to use what's already on the bottom so that we have what's on the bottom. If we simplify the top some more, 1 times w minus 3 is w minus 3 minus this entire numerator minus the entire 1 times w plus 3 is w plus 3. Why is it important that I left that in parentheses? Well, it's because since we're subtracting that whole thing, we need to make sure that we distribute that minus sign. But we'll get there. This was the numerator. The denominator was w plus 3 times w minus 3. And this is all over. Here, w plus 3 times w minus 3, that's a difference of squares. W squared minus 6, sorry, minus 9 plus 9 all over w plus 3 times w minus 3. If we simplify some more, this is w minus 3 minus w minus 3. We'll leave this factored, w plus 3, w minus 3. Here, minus 9 plus 9, those cancel. That's just w squared over w plus 3 times w minus 3. And here, w minus w. This simplifies to negative 6 over w plus 3 times w minus 3 all over w squared. over W plus 3 times W minus 3. Fraction over fraction is fraction divided by fraction. This is still method 1. The other way we could have done it is start by writing this numerator in parentheses divided by this denominator in parentheses. And then we keep going until the numerator is simplified to this, and the denominator is simplified to this. And from here, what do? Dividing fractions, we keep the first, change division to multiplication, flip the second. Now the W plus 3's cancel, the W minus 3's cancel. We're left with negative 6 over W squared. So that's that using method 1. I'm trying to be better about this. Yes, we should be able to understand that that is negative because it's negative over positive. But since it is a negative on the top, let's go ahead and be very specific. Negative divided by positive is negative. How do we know the bottom is always positive? Because we're squaring. So negative 6 over W squared. There's nothing wrong with writing it like this. I'm just, again, trying to be better about being consistent. And I will consistently have a negative fraction before I have a fraction that starts with a negative on top. Let's do this with method 2. Method 1 sure took a long time. The LCD of everything is W plus 3 times W minus 3. We take this one, we take that one, and then by the time we get here, we already have them both. So into the top of each, we shove in times the 1, times the 1, times the 1, and times the 9, the overall LCD. W plus 3 times W minus 3 times the 1 is just itself over W plus 3. Minus, again, since it's just times 1, we end up with W plus 3 times W minus 3 over W minus 3. Remember, method 1, where we're getting it into fraction over fraction, we're just doing a lot of simplifying. There we have to worry about the top and the bottom both getting multiplied by something because we're turning each denominator into the LCD. But with method 2, once we have the LCD, we just shove it in the top of everything. Don't worry about the bottoms. 1 times the LCD is just the LCD. Nine times the LCD over W plus 3 times W minus 3. Things cancel. W plus 3 is here. W minus 3 is there. Both of them there. This gives us W minus 3 minus the entire W plus 3 over W plus 3 times W minus 3 minus 9. Boy, these maths look familiar to me. Distribute the negative. W minus 3 minus W plus 3. Sorry, minus 3. W squared minus 9 minus 9. This should be plus. Go back and fix that. Plus. If you caught that, great job. I did it on purpose. No, I didn't. W squared minus 9 plus 9. There we go. This is negative 6 over W squared. I realized we were about to get a different answer and panicked for a second and said, something's wrong here. I knew that had to be a plus. I knew that had to be a plus, which meant that had to be a plus, which means I had missed it. Okay. So again, I just fixed those are all pluses. But more importantly, we're done. And look, method 2 all fits right here. So we have 2 ways to go to solve these. But the most important way is going to be method 2. Let's do another. Two over x plus 1 minus 1 over x minus 1 all over x minus 1 minus 1 over x plus 1. The LCD of everything is x plus 1 times x minus 1. Let's just do this with method 2. I'm going to take the LCD. I'm going to make sure I multiply each term in the top by the LCD. So that gives me 2x plus 1 times x minus 1 over x plus 1 minus 1 times the LCD. So minus x plus 1 times x minus 1 over x minus 1 all over x times x plus 1 times x minus 1 over x minus 1 minus x plus 1 x minus 1 over x plus 1. Parentheses not required down there. It is the whole bottom. X plus 1's cancel there. X minus 1's cancel there. X minus 1's cancel there. X plus 1's cancel there. All we're left with on the top left now is 2 times x minus 1. And then we're subtracting everything we're left with here because we were originally subtracting the fraction. So we have to subtract everything the fraction reduces to. In this case, we're subtracting the entire in parentheses x plus 1. On the bottom left is just x times x plus 1. We are subtracting, since it was subtracting the entire fraction, we're subtracting what this fraction reduced to, which means we're subtracting the entire in parentheses x minus 1. So the parentheses are very important here. Why? Because we distribute the negatives. And this time they are, in fact, both negatives. Just like we distribute the 2, or just like we distribute the x. We get 2x minus 2 minus x minus 1 over x squared plus x minus x plus 1 . 2x minus x is x, minus 2 minus 1 is minus 3, all over, plus x minus x cancels away, x squared plus 1. Nothing factors further, so nothing cancels further. X minus 3 over x squared plus 1.
The third objective in this topic is simplifying expressions with negative exponents.
Okay, our next complex fraction m to the negative 1 plus n to the negative 1 over m to the negative 2 minus 4n to the negative 1. Now, you might be thinking, what's the trick? This isn't a complex fraction. Where are the fractions inside of the fraction? But it is a complex fraction because negative exponents, they don't have anything to do with negative numbers. Negative exponents turn things into fractions. So this is actually 2 over m to the positive 1, 2 over m to the first. And this is actually 1 over n. The negative 1 exponent is only with the m here. It's not with the 2m. Otherwise, it would be in parentheses. That's why the 2 didn't go to the bottom. The 2 stayed on top because there is no negative exponent with it. But a negative exponent moves to the bottom of the fraction, or if it's in the bottom, moves to the top of the fraction. And it becomes positive. So 2m to the negative 1 plus n to the negative 1 is actually 2 over m plus 1 over n. M to the negative 2 would be 1 over m to the positive 2. Minus 4n to the negative 1 would be 4 over n to the first. So what's the LCD? The LCD of everything is every factor to the highest power we have. So m, n, m squared, that's higher than the m we already have, so it becomes m squared. N, we already have n. So what are we going to do with our LCD? We're going to put it in the top of everything. M squared n. M squared n. M squared n. M squared n. And then things cancel. One of the m's. The n. Both m's. The n. And that leaves us with 2mn plus m squared over n minus 4m squared. This is good. You could also factor out an m, and you'd be left with 2n plus m on the top. Why might we do this? Well, when everything's factored, we can see if things cancel. But since we couldn't cancel an m and we couldn't cancel a 2n plus m, there's no need. We can leave it like this. If you're confused right now why I'm not canceling this m with this m squared, it's because this m squared cannot be canceled. This is all one factor. Factors are things that are multiplied together. So an m can cancel, a 2n plus m can cancel. But we cannot cancel an n, and we cannot cancel a 4m squared. It would have to be this whole thing because this is the factor. So it can't be simplified any more than this. Let's do another with negative exponents. X to the negative 2 over x plus 3x to the negative 1. This would be 1 over x squared over x plus 3 over x. The LCD, x squared. We already have a base of x. What are we going to do with that LCD? We're going to put it in the top of everything. Times x squared, times x squared, times x squared. The x squared cancels. One of the x's cancels. We're left with 1 over x cubed plus 3x. We can factor on the bottom and factor out an x, but we don't really need to because it doesn't make a difference in what cancels out. But either of these are correct. The last one we'll do with negative exponents. 2a to the negative 1 plus 3b to the negative 2 all over a to the negative first minus b to the negative first. Rewriting, this is 2 over a plus 3 over b squared, all over 1 over a minus 1 over b. The LCD, a, b squared, already have an a, already have a b, and it's actually high. Take the LCD and multiply it in the top everywhere. AB squared, AB squared, AB squared, AB squared, NBC. Hey, look, I'm on TV. The jokes never stop. Okay. The A's cancel. The B squareds cancel. The A's cancel. One of the B's cancel. We have 2B squared plus 3A all over B squared minus A, B, minus AB. Only one of the B's had canceled. We can factor on the bottom, not on the top. Take out a B. We're left with B minus A. But it's okay if you didn't do that because it didn't matter. Now, I keep saying it's okay if you don't do that. But keep in mind, if there is ever one that does factor and something cancels away and you don't catch it, that means the answer is wrong. So even though you can leave it here, should you? Really? So to clarify everything I've been saying about these negative exponents, x to the negative 2 is 1 over x to the positive 2. Y to the negative 2 is 1 over y to the positive 2. A negative exponent travels to the bottom as a positive exponent. A negative exponent is sort of a reciprocal, but with a positive exponent. On the bottom, the negative 1 power is only attached to the x, not the 5, so the 5 stays put, and the x travels to the bottom. X to the negative 1 is 1 over x. X to the negative 1 is a reciprocal. Same over here with the 2y to the negative 1. The negative 1 is only attached to the y. It has nothing to do with the 2. So the 2 stays put, and the y to the negative 1 becomes 1 over y. So our complex fraction is 1 over x squared y squared, all over 5 over x plus 2 over y. All we've done is rewrite the original given rational expression that had negative exponents in it with positive exponents. It's always been a complex fraction. We could just see it as a complex fraction now.
Our LCD, our common denominator unique factors would be x and y. Highest power of x is squared, highest power of y is squared. So we're going to multiply by x squared, y squared over x squared, y squared. X squared, y squared over x squared, y squared on top cancel away, just leaving us with a 1 on top. X squared, y squared over x times 5. So take this x squared, y squared and multiply it by the 5, divide by the x. We get 5x y squared. Take the x squared, y squared and multiply by the 2, divide by the y. We get 2x squared y. So 1 over 5xy squared plus 2x squared y. That was using the LCD method. That was using method 2. A good exercise may be trying on your own to do method 1 and see if you get the same answer. And that is it for this topic. The topic is dividing polynomials, long division and synthetic division. The first objective in this topic, dividing a polynomial by a monomial. So in order to divide a polynomial by a monomial, in other words, to divide by a single term, we divide each term in the polynomial by the monomial. So if we have a plus b divided by c, we would do a divided by c plus b divided by c. Obviously, since we're dividing by c, c can't be 0. So let's take a look here. Negative 12a cubed plus 36a minus 15. We would divide each term by 3a. The negative 12a cubed divided by 3a plus the 36a divided by the 3a minus the 15 divided by the 3a. 12 over 3 is 4. 36 over 3 is 12. 15 over 3 is 5. A cubed over a is a squared. A over a cancel each other out. And in the third term, the a stays on the bottom. So negative 4a squared plus 12 minus 5 over a is what we get when we divide. Now you could use the quotient rule. A cubed over a would be a to the 3 minus 1, which is a squared. Or you can think of it as 3 a's on the top, 1 a on the bottom. One of those a's cancel out, leaving no a's on the bottom and 2 a's on the top. Let's divide 10t to the 4th minus 35t cubed plus 5t squared by 5t squared. So we divide each term by 5t squared. The 10t to the 4th divided by 5t squared minus the 35t cubed divided by 5t squared plus the 5t squared divided by 5t squared. 10 divided by 5 is 2. 35 divided by 5 is 7. 5 divided by 5 is 1. T to the 4th over t squared is t squared. T cubed over t squared is t. And t squared over t squared cancel each other out. In fact, just looking at that plus 5t squared over 5t squared, anything over itself is 1. So that's plus 1.